Hello everyone. Okay, now we're going to run through the actual script that I have built for you. It's mostly pulled from the book, from section 7.1 and 7.2, that shows how we can actually set up to run a kNN classifier. I dropped off at section 7.3 and 4 because I didn't want to go into that level of detail. I did stray a little bit away from the book, though. The book actually classifies a single record, and I classified 4. So I've created a data file that actually has 4 new records in it. And we're going to run through this. I put a lot of comments in the script, and the script is posted to Canvas shell in Module 7. But I want you to run through it and just get a feel for everything that is in it so I can explain the actual commands, because your assignment is going to be to modify this script and make it do something different. Okay, first things first, comments. kNN classifier tells you a little bit about the file. And we have 2 data files that we're loading. Both of those, again, are in the shell in Module 7. The first one is the mower.df file that we saw in the previous presentation. That is a CSV file, and it's called writingmowers.csv. Go ahead and put it in your working directory and pull it into your environment. And then the second one is called new.df. Those are the 4 new records. And I called that file newcustomer.csv. That should also be up in your module. You can just read that in. You can call it, I called it new.df. Okay. So now what we're going to do is we're going to divide the mower data frame, the one that we just created up here, into 2 mutually exclusive files. And so these will be named train and valid. This is our training set and our validation set. We'll build train by taking 60% of mower.df data frame, and we will build valid by taking the records that are not in the mower.df data frame, basically everything that didn't get selected the first time. First thing we'll do is we'll set the seed so that the random record selector is initialized. And now we'll go ahead and build those indices that separate mower.df into train.df and valid.df. So train.index is going to be set equal to, we're going to do a random sample, and the random sample is going to be of row names in mower.dataframe. So these are just basically numbers of the rows in mower.dataframe. And we're going to take 0.6, basically 60%. This is the equivalent of 60%. So 0.6 times the dimension of mower.dataframe. This is a fancy way of basically being able to take 60%. So what we do is we run a dimension function on mower.df, and it's going to give us a value, and we're going to take the first value, and then we're going to take that times 0.6, and that's going to be the number of records, and it's going to do a random sample of that number. Well, I happen to know that there are 24 records in mower.df. If you take, and that's what we get when we actually take the first entry into the dimension. If you take 0.6 of that, you're going to get 14. So you're going to take a sample of row names from mower.df, and that number is going to be 14. You know, if you know how many records you have in your data frame, then you can just go ahead and do this by hand. But this is a fancy way of being able to not have to do that. Your data frame can be 14 records, or it can be 14,000 records, and you don't have to worry about the difference here. So anyway, that's taking a sample of 14 records from mower.df, and it's just pulling in actually the row numbers, row names. The next thing we're going to do is we're going to create our index for the valid file. And that's basically say, set the difference. Give me everything that's different in the row names from mower.df and train.index. Okay, so it's basically give me everything you didn't pick in the first one. All right, now what we're going to do is we're going to build those files. So we'll use the indices that we created to build the data frames. So train.df is going to be set equal to mower data frame. Now we're using the square brackets because we're going to identify the specific rows we want. Those specific rows are indicated by the index that we built above, and we select all columns. Same thing with valid. Valid.df is going to be set equal to mower.df, our valid index, which is designating the rows that we want, but we want all columns, so that's just comma and space. All right, we're all good there. Then the next thing we're going to do is actually let's run through some of these. We're going to need to actually look at the plots. So I'll run through these commands. Everything is set up. Okay, and we should have our, don't see any errors, everything looks good, our data frames are set up. Now we're going to run it to scatter plots. Back a little bit on the smaller screen here. All right, so now we're going to do visualization of the data points because we want to see what we got. And some of these are owners and some of them aren't. Remember, we did random selection of 14 records from our data frame. So we got some owners and we got some non-owners. We're going to use a couple of things on our scatter plot that we've never seen before. So I wanted to run through those. Some of them are pretty cool, actually. First one we're going to do is we're going to set PCH. PCH is a variable that basically says If you've got data points in your scatter plot, you can make those look however you want. And every number in the PCH sort of spectrum is a different shape. It could be a plus, it could be a circle, it could be a square, it could be a triangle, whatever you want. You just have to, and you can look on the web and find the PCH table to see what those values are. But you set your PCH in your scatter plot, and it will point, instead of having just dots, it will have something that is maybe a little different. But you might want to have certain values set in one way and other values set in another. And so this PCH equals if else allows us to differentiate between one value and another. So if one value is set, or if a variable is set to one value, use one value of PCH. If a variable is set to a different value, use a different value of PCH. And what that's basically going to do is it's going to say, okay, for every one that falls into the first bucket, I'm going to give you a triangle. And for every one that falls into the second bucket, I'm going to give you a circle, or a plus sign in a circle, or something, whatever numbers you select for the PCH values. So we'll see how that works. It's actually built right into the way that we generate the plot, and it looks pretty cool. We do generate the plot first, and then we come through and we set those PCH values, which is also something we've never seen before. Typically, when we've generated a scatter plot, it's been a static scatter plot, and we've not ever gone back to change it or fix it or alter it in any way. But we can do that with the text command, and so we'll see that as well. So anyway, I finish out with my comments here. This will set the PCH to 1 if the data point is an owner, and 3 for a non-owner. We'll see the format of that command below. Those records with PCH set to 1 will be indicated with a circle. Those records with a PCH set to 3 will be indicated with a plus sign. Please pay attention to the fact that double equals, it's kind of counterintuitive, but double equals in R is not equal to. It's the same thing in Python as well, by the way. So here's our plot. We're going to plot lot size against income. Data set is going to be the train.df data set. Our PCH is set equal to if else train data frame ownership not equal to owner. Okay, so if it's equal to owner, it's going to be set equal to 1. Else, if it's not equal to owner, it's going to be set equal to 3. And you can see that format is set up. It's a pretty cool format. It's a pretty complex format, but it allows us to do some pretty cool things with the way that we set up our data plot. Okay. Now we're going to use a new command also on our plot. It's called text. And text allows us to make modifications to the data points that are actually on our plot, our scatter plot. So the text command is used to modify the scatter plot. The first command adds row names, which we want. And then the second text command is going to bring in those 4 new records, the ones that we haven't really done anything with, and it's going to plot them on your scatter plot. So you'll be able to see how those 4 records look visually when compared to the existing records. This starts getting us into the mind of thinking about classifications, because if we can see the difference between the 2 classes, Class A and Class B, or owners and non-owners, and then we see the 4 records and how those 4 records look visually and what the distance is between the 2 different classes, we might be able to get an idea of what we're doing with those 4 records. Okay, the last thing we're going to do is we're going to use the legend function, and it will build a legend for us in the top right of our scatter plot so we can see what's going on. All right, here's the first text command, text. We're going to, for train data frame income variable, using, and also for lot size, the 2 variables that we are concerned about, we are going to ask the train or the text function to put in row names. The POS equals 4 is the position around the data point where you will put this. It's either top, bottom, right, or left. So the position value is going to be 1 through 4. Okay. So what this first variable is actually your x coordinate. What the second variable is your y coordinate. So for every x, y, you're going to go ahead and put a row name in there, and that row name is going to be basically the number of the row. Okay, and then it's going to be position 4, which is going to put it in the right position relative to the data point. Let's go ahead and run this plot and at least catch up to where we're at. All right. There's our plot. Okay, we have circles and we have pluses. So that's our PCH1 or PCH3. All right. The next thing we're going to do is we're going to go back and we're going to run these text commands. So we'll run this, and set up our legend. And now let's go find our plot, which is here somewhere. Okay, I'm on the smaller screen, so it's a little tougher to see. But you can see that we have our lot size versus our income. That is our plot. We saw that before. Now we have our data points, and they're labeled with the row numbers. And we have our legend. If this was on full screen, your legend wouldn't sit on top of your data points. You see data point 8 is here, and that's not exactly ideal. But we'll go ahead and work with it anyway. We have also the new household. We have another data point behind new household. We have the new household indicated with X's. And these are the 4 records that I have brought in. And I have plotted those 4 records. Now, how did I plot those 4 records? It's the same kind of way. I have to find this now, which is down here, that I did the text command before, right? So I had the text command, which was indicating with the original, these are the classified sets that we've set up, the records 1 through 14. And then I brought in the new records. New records, the text command is looking for an XY coordinate. So in my new file, I had income for every record, all 4 of my records. I had also lot size for all 4 of my records. That makes up my XY. And now instead of plotting something that I'm pulling from a file, I'm just going to plot a character. So the character is X, and it matches the character that I'm using in the legend. This is a commented out one. This is the original script. If you look in the textbook, that's what it was doing. I commented it out so that I could actually do the 4 records from the data file instead. And then I set up my legend. Top right, and it's a vector. It's got the values owner, non-owner, new household, and the PCHs equals C1, 3, and 4, which match the values that you see on the plot. So that gives me my plot. And with my plot, I can start looking at how do these records shake out. Actually, how do they look when I am plotting them? There are 2 of them down here. These are new records, and they're surrounded by plus signs, and plus signs are non-owners. So I'm beginning to think that the majority, remember I said k equals 3, or well, I actually haven't, but I'm going to say k equals 3. Probably these are going to wind up being non-owners, and that's how we will classify them, because, you know, from a distance standpoint, if we calculate the actual Euclidean distance between these points and the nearest 3 points, we will probably come up with a value that drops them into the non-owner category or class. The other 2 are up here, and these are hanging out with the owners, right? There are owners. 9 is an owner, 12 is an owner, 8 is an owner. I believe 10 is an owner, but that's probably too far. 20 is a non-owner. So if you're looking at this data point and you calculate the distance between 9, probably 12, I'm guessing, and 20, could be 1 is closer. You'll see that in this particular case, let's assume it's 1, 20, and 9. In this particular case, the owners, actually, the owners, 9 is an owner, 1 is an owner, the owners outweigh the non-owner, because remember, the majority rules. So that's probably going to wind up being an owner. And this one up here, probably closest to 9, 12, and 8. All 3 are owners. We're probably good there. But let's verify it. So let's go back to our script. All right. We got a couple other things we got to do before we are going to be ready to run the kNN classification step. And that is, we have to now normalize our data set. Remember, the data set should be normalized so that the values, the variables that have the broader ranges, don't take more weight than everything else. We want everything to have the same level of weight. Okay, so how do we do that? All right, now given the visual, what predictions can we make? We already looked at that. We're going to run the kNN classifier next, but first we're going to normalize the data. And when we normalize the data, we're going to calculate z-scores. All right, z-scores. To calculate a z-score, if you remember from statistics, you calculate the mean of a column of data, you subtract the mean from every one of the elements that was used to actually calculate it, and then you divide that by the standard deviation. That's more statistics than you need to worry about. Let's just get to the commands. Okay, so we normalize the data. We initialize the normalized data. First of all, we'll set up our data files. So we're going to set up a data frame for train.norm. That's the normalized data for training. We're just going to copy in that data frame train.df. Same thing for valid, and same thing for mower. Okay. Now we're going to bring in a new command, the preprocess command, and the preprocess command is what we use to build the model that we can then apply to all of our data sets. We have to bring in 2 new packages, so if you've not installed these packages, go ahead and install these packages. You know how to install packages. You can come up to the top when you're actually in the main console. You can come to the top and do install packages, or you can do it pretty easily in RStudio. We'll pick out this package, and we'll install those and then run the library commands to bring them up and make them live. We don't actually need the second one until the end. Let's just do it now anyway. Okay. So we are going to set up a model, a normalization model called norm values. it's going to take on the results of the preprocess command where we take train.dataframe and we take the two columns we care about, all rows, and the two columns we care about, which are income and lot size. And the method we're going to use is going to be a vector that contains center and scale. This center and scale, by selecting center and scale, we are calculating z-score. The number of options you have to specify with method is very long, and probably many of them can be used for different reasons. We're going to use center and scale because that's going to give us z-score. So anyway, what we're doing, we are creating this data frame, train.df. We're actually creating this variable, this model, using our training data frame. We're calculating z-scores, and this is basically how do we then set up a process to normalize our file. We move on below, and we are going to now normalize train.norm.df, valid.norm.df, and mower.norm.df. We're going to normalize all rows and the first two columns, and we're going to do that by running the predict command. What the predict command does is it takes the output of the preprocess command, which is norm values. It takes that model and it applies that model to the data set and runs the normalization on the data set, and we drop the results into this file. So we'll do that for all three of those data frames. And by doing that, we're converting the values in train, norm, valid norm, and mower norm to z-score scales. We'll have one more that we have to do. We have to do the same thing for our new file. Our new file was our new.df. Now we've called it new.norm.df. We're going to apply the z-score normalization on that. That's the original file, and we'll drop those values into new.norm.df. What I'm going to do is a bit of good for us to take train, valid, and mower and convert those to z-score scales if we don't also convert the new norm to z-score, because when we do our Euclidean distance, if they're not on the same scale, it's going to be a mess. So we've got everything all set up now. Everything's normalized. We're all on the same scale. We're all z-scored. And now we can come down here and get ready to run our kNN to compute the actual classifications, to actually determine the classifications of our 4 new records. To do that, we will run the kNN classifier. Our training data is our train.norm.df. That's our normalized data. We're going to use all rows. We're going to use the first 2 columns. Our test set is new.norm.df. That's the data that we're going to classify. It's got those 4 records in it that we want to know what class they belong into. Okay. The class we're going to use is another field in train.norm.df that we didn't do anything with. We didn't normalize it. We didn't mess with it. We didn't touch it. It's the class that determines whether or not the particular record is an owner or a non-owner. So when we look at new.norm.df and compare it to train.norm.df using the kNN classifiers, we are going to worry about this value in the 3rd column, owner or non-owner, and we're going to assign it to these 4 records based on how they compare out between the train and the new. Right? It's kind of what we did visually when we brought up the scatter plot. We looked at the 2 records in the lower left. Those ones probably were going to be non-owners, and the 2 records in the upper right, those ones were probably going to be owners. Okay? And we also set our k equal to 3. This is where we determine the number of records we want to look at. This could be 5, this could be 1, but 3 seems to work in this particular data set. It's a pretty small data set. So, again, to recap, what we're going to do for every one of our records in new.norm.df, we are going to take a look at that record and we are going to compare it to all 14 records in train.norm.df using columns 1 and 2. And then we are going to make a determination as to what the class should be. The class will come from train.norm.df column 3, because that's where we designate owner or non-owner. And again, we're looking at the 3 closest records. Right? That drops all of those results into a variable called NN. And now we can look at the results by doing either a summary or NN. I'm actually going to put a different command in there also. Print. And we can see of the 4 records we have, how did they classify out? And then we can just run a real quick view of new.df so we can see the 4 rows and compare them to the class. Let's go back and run some of these. Let's see, I've forgotten actually how far back we went. I think we got, yes, to here. We'll run the normalizations. Load the libraries. Set up our normalization model, apply our normalization model to our 3 data sets and to our records to be classified. Now we're ready to run the kNN. It gets run, and we can look at the results. I'll run the summary command first, then I'll run the print command, and then we'll take a look at view. There's our view. Okay, so we can look at we'll set this aside for now. Let's go back to our console. Go up and over. Okay, if you remember, first thing we did was a summary of NN. It tells us 2 of our records are non-owners and 2 of our records are owners. Okay, that's great, but that doesn't really help us that much because we don't know what's what. When we do the summary, or the print of NN, it gives us the order. So non-owner, owner, owner, non-owner. Okay, well that's why I did the view. If you remember, I've got a view command in here. I've got to find it. And it will give me the owner or non-owner status based on, I'll pull this up here. Come on. I think we can see it well enough. Okay. So, non-owner, owner, owner, non-owner. Okay, well if we look at this and we compare it to our plot, pull this over. The first record we have, income is 60.05, lot size is 17. 60.05 is over here, lot size is 17. That's our record right there. And it says, if you remember from our results, it is a non-owner. That's not a surprise. That is exactly what we expected it to be, a non-owner. Okay, the next record we have is 71.25 is the income, and 19 is the lot size. It's going to be up here, 19 at 71.25. That one's classified as an owner, and that's not a surprise either because it's closest to the owners. If we look at record number 3, 75.50 is going to be over here. It's going to be up here. That's our record right there. It's also classified as an owner. And then our fourth record, 55 is the income. It's down here. It's at 16. That's that record right there. It is classified as a non-owner. So it looks like everything worked just exactly as we wanted it to. We were able to take our 4 records. We were able to visually look at those records on our scatter plot. And we were able to then run through, normalize the data, run the kNN classifier, and come up with a result that in fact matches what the visual shows. So that's what I'm going to have you do this week. Instead of actually running through this, which I think it's a good idea, if you bring in the script is sitting in the canvas in the module. If you bring in the script and you run through it, you'll get a feel for kind of how it all works, and you'll be able to see it. And I apologize for the small screen and having to navigate around. For some reason, my Screencast-O-Matic has decided to glue itself to my small screen, and that's become problematic in being able to sort of show things in large scale. But anyway, we got through it. So here's what I want you to do. I want you to run through that file, run through that process with the training.df data frame. Now, the other thing I want you to do is I want you to validate the results. So we got non-owner, owner, owner, non-owner on those 4 records. But we did that against the training data frame. What if we ran it against the validation data frame? Remember, there's a validation data frame, and that has 10 records in it. Not a big data frame, but it's big enough. Can you modify the script? I want you to modify the script to actually validate these results and tell me, do they come out to be the same? Okay. That means you're going to have to go in the script, and you're going to have to figure out all of the places where you need to take train.df out and put valid.df in. And then you're going to have to run through this, generate the plot, show the plot against your 10 records, run the normalization process, which is pretty much already set up for you. Then you'll run the kNN cluster, you'll do the summary, you'll do the print, and then you'll do the view, and you can tell me if the file looks the same. Okay? So what I want you to turn in is I want you to turn in 2 things. One, I want you to turn in a screenshot, kind of like what I'm showing right now, that shows the plot and shows the view. It shows kind of that, yeah, in fact, this does kind of look like it's supposed to look. And the other thing I want you to show me is your script, after you've modified your script. So the screenshot can be just dumped into a Word file, and the script is just a .r file, so you can upload both of those, and that will be your assignment for the week. And I've already described that in your assignment for the week, so I think you should be good to go on that. Let me know if you have any questions or concerns, and I will look forward to seeing your results.